Hi, everybody, and welcome to this week's lecture. What essentially we're going to try to accomplish today is we are going to look at the atomic level, and we're going to be specifically identifying and describing the composition of living organisms. We're also going to look at atoms, and we're going to look at those basic components. So not only are we going to understand exactly what an atom is and what they have to do with biology, but we're also going to be able to read and distinguish between the subatomic particles of an atom. Now, again, this week is going to be separated into two parts. So again, in our first part, these are the major ideas that we're going to be focusing on. So let's go ahead and get started. Let's go and take a look at the connection between biology and chemistry. So why are we learning about chemistry prior to really getting into our biological functions and all of those different things? Well, one of the big reasons as to why is because chemistry is the study of matter. And matter makes up everything. Depending on its orientation and depending on its physical and chemical properties, it's going to dictate a lot of the way things operate and the way things work. And when it comes to biology, it's all about the study of life. So these are naturally going to go hand in hand because, again, everything is made up of matter. So again, life is composed of matter. So this kind of brings us to our first question, which are what are the tiniest components that living things are made out of? So again, we're trying to still connect the idea of bio and chemical. And over here, you'll notice that there's a table that outlines majority or many of the different elements that comprise of a person. Now, what you can see here is we have a bunch of different elements. We have oxygen, carbon, hydrogen, nitrogen, calcium. We also have their chemical symbol, and typically their chemical symbol is just going to be the first letter of their word. Sometimes they might be slightly different. Great example is carbon. Chemical symbol is going to be a C. And we have calcium, which is going to be a Ca. So sometimes we will use a different letter or utilize a second letter in order to differentiate between the two. Typically, when you write a chemical symbol, the first one is going to be a capital letter, so just like C, and then the second one is going to be a lowercase a. So going back to this idea here, biology and chemistry, what is that connection? What do those have to do with each other? Well, again, chemistry is study of matter, and biology is the study of living things. And because everything is made out of matter, it's important to understand exactly what those physical chemical properties are, how those natural chemicals and elements come together in order to produce something that can be very complex, such as the human body. Again, looking at this over here, you can see that we have another visual breakdown of all the different things that go into making a person. And again, when we separate all that out, they're all made up of those individual elements. And again, all an element is just a singular substance that is going to be our smallest denominator. So again, these elements are going to be found naturally occurring, and they are going to be the smallest or starting points or building blocks of life. So let's check out elements and the living world. Now, again, to understand all of this, we need to know that matter is elements, and everything is made up of matter. And our elements that we're going to be looking at have some specific properties about them. First one, physical. So all different elements do have a specific physical property. Remember, anytime we talk about physical, it's going to be specifically touching on our five senses. So anything that we can observe, touch, smell, taste, hear, all of those things. Now, when it comes to chemical properties, that's going to be slightly different. We aren't going to really be able to observe or see these, but more conceptually, we would be able to understand exactly how they're binding. So this might get into things like covalent bonds, their positive, negative charges, things like that. Now, remember, elements, they cannot be broken out into smaller substances because these are going to be our starting points or building blocks. So again, these are our smallest denominator. They are going to be naturally occurring, so you will be able to find these in nature. And elements, just like we talked about previously, do have chemical symbols that will denote which ones are going to be what and how to differentiate between the two. we're also going to check out atomic numbers along with the atomic weight and masses. Okay, so this is going to be very important as well, because depending on our atomic number and our atomic mass can drastically change these two. It can change the physical properties of that element. It can also change the chemical properties of that element as well. So let's go ahead and take a look as to how we're going to be able to view these, how we're able to understand these, and what resources do we have available to us. So right over here, you'll see that we have something known as a periodic table of elements. And what this does is this categorizes and organizes all of our different elements, not only in our atomic number. You can see hydrogen is our first one in our first group. And you can see that as we're moving down, 1, 2, 3, 4, 5, they're all going to be in numeric order. So this is going to organize the atomic number. You'll also notice that as we're increasing, we're also going to be increasing our atomic mass, or how heavy the elements actually are. You'll see that each one has a symbol, which again is going to tell us what type of element this is going to be. So you can see Li, lithium, you can see B is going to be boron, C is going to be carbon, Si is going to be silica, things like that. Again, remember, whenever we're using our symbols, typically it's just going to be 1 or 2 letters. So again, we typically use, let's say in this case of hydrogen, capital H to represent the hydrogen, but sometimes we'll go ahead and use 2 letters. If we use 2 letters, it's going to be 1 capital. So in this case, lithium, it's going to be L, so capital L, and then an I, and that's going to be a symbol for lithium. And then finally, right below, we are going to have the name of the actual element itself. So again, this is our periodic table, and this is going to be a really powerful tool to kind of help us understand and quickly see, organize, and identify our different elements, along with giving us very, very strong and important pieces of information, which we'll kind of talk about more, specifically the atomic number and the atomic mass in the following slides. Now, after this, there are going to be a couple questions, some practice questions that I would like you to do. What I'm going to do is I'm going to go ahead and show you them, and then I'll give you a moment to pause the video, maybe go back or look up the periodic table to identify each different elements. So let's go ahead and test your knowledge. So go ahead and take a moment, pause this video, and see if you can answer number 1, which is identifying all of these different symbols. Same thing with this one over here, identify these symbols over here. And then for number 2, seeing if you can do the opposite. Take these symbols and tell me if you can identify what the actual names are for these. And then for number 4 and then number 5, what you're doing is you're looking to see if this capital C, capital A is going to be calcium, and see if lowercase c and lowercase l are going to be the chemical symbols for chlorine. Okay, so I'll go ahead and give everybody a moment to pause this video, go back and see if you can answer these questions. All right, so let's go ahead and check out some of those answers. So this is where you can compare to see if you got those correct or not. I'm not going to touch on 1, 2, or 3, but I do want to touch on 4 and 5, because this is where a lot of students do kind of get messed up on. For this one, we have C and A, and we're looking for calcium. So some students, if we go back here, we're going to go ahead and find calcium. So we're going to go ahead and look for it right here. And it's indeed a C and an A, but in this case, it would be false. The reason why is because this is saying that C and A is the chemical symbol for calcium, but in fact, it's a capital C and a lowercase a. So this would be the symbol for calcium. And then the same thing for this, lowercase c and lowercase l would be false as well. This would not be the correct chemical symbol, because in chlorine, you need a capital letter first and then a lowercase. Okay, so moving on, we're going to now break down the atom, specifically what it entails, what's going on with it, and how we can actually use those atomic numbers and atomic masses to identify what's going on. So when it comes to an atom, there's going to be 3 basic pieces in our element. So over here, you can see we contain 2 regions. So the first part is going to be the nucleus. All the nucleus is going to be is the center point here. And then when it comes to our nucleus, we have two different components that make that up. We have our protons, which is our positive, and then we have our neutrons, which is going to be neutral. So the way that I kind of remember that is pro equals positive, and then neutral or neutron equals no, meaning that it does not have a charge. So pro, positive, neutral, or no charge. And then on the outermost portions of an atom, we have electrons. Now, electrons are going to orbit that, meaning that they're just like the planets, going to spin around the nucleus. And our electrons are going to have a negative charge, which is going to be negative. So pro, positive, neutral, or neutrons, no, and then electron are going to be negative. So all of these together are going to be known as our subatomic particles. Because again, we're looking at our atom, our atomic particle, which is this entire piece here. And then our subatomic are our individual pieces that make it up. So again, we have our proton, neutron, and then our electron. Proton positive, neutron neutral, and then the electron is negative. So let's go ahead and check this out a little bit further and use an element as an example. So in this case, we have an atom of helium, right? This is our element. We're looking at our atom, which is all of the pieces that make that up. And then right here, we have our tile from our periodic table. Now, there's going to be two questions that we're going to want to check out when it comes to comparing these two. The first one is helium atom has an atomic mass of 4, right? Which we can see right over here. And then we have an atomic number of 2, which we have right over here. So based on what you know, would this work? Does that make sense? So when it comes to our atomic mass, it has to do with our neutrons and then our protons. So in this case, we have an atomic mass of 4. So we have 1, 2, 3, 4. So in this case, our atomic mass, or how heavy it is going to in fact work. And then the 2 here is just telling us how many electrons we're going to have along with our protons. In this case, electrons, we have 1, 2, which checks out here. And then over here, we have 1, 2, which checks out here as well. So in this case, we know we have 2 proton positive, 2 electron negative. And then our mass, again, we have 4, and that matches over here as well. So that's what this is kind of translating or telling us. It's showing us our subatomic particles and all the information we need in this singular tile. So now that we've identified that, we can go ahead and move on to number 2, which says, does the information in the diagram agree/disagree with the information about the helium in the periodic table? In this case, it would agree, because again, we have our atomic number, our atomic mass, telling us some important pieces of information, which can all be translated from this atom over here. So there's a couple key properties that we do need to understand when it does come to subatomic particles, and it does kind of play into our mass. And this is a way to kind of help you remember what the mass entails and what the atomic number entails. So remember, protons, pro positive. We have neutrons, neutral, or in this case, neutron, no charge. So we don't have any charge here. And then electron is negative. Again, we see our charges over here. And we can see that our masses are only coming from our protons and our neutrons. So if we think back to our helium, we had an atomic mass of 4. And the reason why is because in our nucleus, we had 1, 2, 3, 4, which made up, again, our proton, our neutron. Because they each have a mass of 1, we could have counted 1, 2, 3, 4, giving us the atomic mass of 4. And again, they're all found in the nucleus. Our electron does not have a charge, and they're found in the orbits. So again, in this case, orbits, remember, are orbiting around. We had 1 and 2. They were negative, and that also gives us our atomic number because it also tells us how many protons we have. So again, we had 2 electrons, and then we had 2 protons. So these are the key properties that help us differentiate and dictate what our atomic mass is and what our atomic number is going to be. Okay, so what is the significance of the atomic number and atomic mass? I know we kind of already talked about this, but we're going to touch on it a little bit more. Again, our atomic number is the number of electrons and protons. Remember, electrons negative, protons positive. Our symbol, remember, is going to be 1 or 2 letters. And then our atomic mass is going to be everything inside of the nucleus. So remember, our nucleus had our protons and our neutrons. Protons and neutrons are the only ones that have mass, and our electron does not have any mass. So the reason why this is so important is because you can actively use all of that information in order to figure out exactly how many protons, neutrons, or electrons we have. Because we know that the atomic number is going to be our positive, negative protons and electrons, and we know down here it's going to be our protons and neutrons, we can actively use this to subtract from the atomic mass in order to identify how many neutrons we would have. So again, we know how many protons and electrons we have. We know this has our protons and our neutrons. So if we ever need to figure out exactly how many neutrons we have, all we'd have to do is subtract. So let's go ahead and practice that out. You'll see over here that we have 2 different elements. We have our potassium here, and then we also have our carbon over here. You'll notice that our potassium has an atomic number of 19 and our atomic mass of 39.10. In this case, whenever you come up with numbers like this, just round to the nearest whole number. So in this case, we'll be utilizing 39. Same thing down here, 12.01. We're going to be using 12 as our atomic mass unit. So what I want you to do is I want you to go ahead and take about a minute or two to see if you can identify how many protons, neutrons, and electrons we have. Okay, so go ahead and pause the video and figure those out. All right, welcome back. So let's go ahead and see how you would have calculated this out. In order to identify the number of neutrons, again, we already know how many protons we have. So protons equals 19. We know we have electrons, which equals out to 19. So we're only trying to figure out how many neutrons we have. Again, we're going to go ahead and subtract that out. So if we go ahead and take 39, remember rounding to the nearest whole number, and then we're subtracting that with 19 right here. So this means that if we subtract 39 from 19, it should leave us the value for neutrons. Now, the neutrons aren't always going to be the same as the protons and the electrons, but because they don't have a charge, it won't affect the positive or negative of the actual atom itself. So in this case, when we calculate this out, we know that we have 19 protons, 19 electrons, and we have about 20 neutrons. Okay, so go ahead and do the exact same thing for carbon down here. Again, figure out exactly how many protons, neutrons, and electrons we have. I'll give everybody a little bit of time to pause this to figure that out. All right, welcome back. So let's go ahead and see how you would have set this up in order to answer this problem. Looking at this over here, remember we're rounding and using our nearest whole number. So in this case, we're going to use 12. So again, we know that our protons are equal to 6. We know that our electrons are going to be 6 as well. And then we know that our entire proton plus neutron is equal to 12. So we're just trying to figure out how many neutrons we have. Again, we can subtract out our atomic number because that's telling us the number of protons subtracted by this, which is our nucleus or protons and neutrons together. So we take our 12 minus 6, leaving us with 6 neutrons. All right, awesome. So right over here is another test your knowledge. So you might have to use your periodic table again in order to answer these questions. One quick thing I do want to mention is you do not need to memorize the periodic table. You just need to be able to understand how to read it and pull the information from it. I will never have you memorize it. Anytime that there is going to be a test or a quiz, it will always be provided to you. So same as last time, what I'm going to do is I'm going to go ahead and give everybody a little bit of time to pause this video, answer some of these questions, and then we're going to go ahead and check out some of the answers. Okay, go ahead and answer number 1 all the way through 6 now. All right, welcome back. So let's go ahead and check out some of these answers. Okay, so number one, in this case, we should have identified the atomic number, the atomic mass. So remember, the atomic number is the number at the very top. The mass is going to be at the very bottom. So in this case, it should be 1531. Same thing over here, mass and number. For oxygen, we know that the number was up here, the mass was down here. So then that should have been 12 and 6. And then the atomic mass is representing what? Remember, the mass is going to be the nucleus. The nucleus is going to be in the middle with our protons and our neutrons. So it should have been C. The atomic number represents what? So again, the atomic number, which was at the very top right here, is always going to represent a number of electrons and our protons. So think about the number right up here is equal to the charge or positive or negative. So it's always dealing with our protons and our electrons. Number 5, how do you find the number of neutrons? You're taking your atomic mass subtracted by the atomic number. So remember, mass is protons plus our neutrons, and then our atomic number, remember, is going to be protons and electrons. In this case, we're going to use or make the assumption it's just protons. So protons subtracted by protons right here is going to leave us the number of neutrons. And then finally, this was an example. How many neutrons are represented in each atom of sodium? The atomic mass was 23. The atomic number was 11. Again, if we take the mass, 23 minus 11, that should have given us 12. All right, and just like that, that concludes our part 1. So if anybody has any questions, comments, concerns, please feel free to reach out. I'd be more than happy to either explain something in a different way, re-explain something, maybe do some practice problems, whatever you'd like to kind of help you get the best understanding possible. So again, that concludes part 1, and I'll see you in part 2. Have an awesome rest of the day, everybody.